Welcome back, everyone. Yesterday we learned about arc length, and we've learned about arcs and chords separately. Today we are working on Goal 5. We are going to recognize and use the relationships between arcs and chords. So we're going to talk about arcs and chords together. First of all, you need to know this theorem. It says that in the same circle or in two congruent circles, two minor arcs are congruent if and only if their corresponding chords are congruent. Remember, this phrase, if and only if, means that this theorem works in both directions. So we can say that if the arcs are congruent, then the chords are congruent. We can also go the other way. If the chords are congruent, then the arcs must be congruent. So let me show you what that looks like on this picture. If we know that these two arcs, FG and JH, are congruent, which can also be marked with a congruent symbol, then we know that these chords, F, G, and J, H, must be congruent as well. It also works the other way around. If we know that the chords are congruent, we can conclude that these corresponding arcs are congruent as well. Let's try an example together. It says in the embroidery hoop, segment AB is congruent to segment CD, and the measure of arc AB equals 60. Find the measure of arc CD. Since we know that segment AB is congruent to segment CD, I can also conclude that arc AB is congruent to arc CD. This means that the arcs have to have the same measure. So if the measure of arc AB is 60, that means that the measure of arc CD would also have to be 60. Go ahead and try the practice problem below. Here's the correct answer. Now this also works with algebra. If you are given that two arcs are congruent, as seen in this figure, it says that these two circles are congruent, and we know that the two arcs are congruent. Then we know the two chords must also be congruent. So I know chord MN has to be congruent to the chord PQ. Those two segments are congruent. Whenever two segments are congruent, it means that their measures are the same. They're equal. So I know MN equals PQ. So I can solve this equation 2x plus 1 equals 3x minus 7. So first thing I would do is add 7 on both sides and subtract 2x on both sides to get x equals 8. But remember, I'm finding PQ, so I'll have to plug that back in. So I have 3 times 8 minus 7. 3 times 8 is 24. 24 minus 7 is 14. So I get PQ equals 14. Try the similar problem that I have listed for you below. Here's the correct answer. And finally, I want you to reflect on this question. Is a radius a chord? Is a diameter a chord? Explain in 1 to 2 complete sentences. Tomorrow, we are going to be talking about recognizing and using the relationships between arcs, chords, and diameters. So come back tomorrow to learn about how arcs and chords also relate to diameters. Talk to you then. Bye.